If you're a user of AEMC instruments, you may have come across the terms true RMS, true InRush, and/or true Megohmmeter. In this video, we'll briefly define what these terms mean and why they are important to you. The most well-known of these is true RMS, an industry term for a method for calculating root mean square. As you may recall from a previous AEMC video, root mean square, or RMS, is a mathematical concept used to derive the average of a constantly varying value. In electronics, RMS provides a way to measure effective AC power that allows you to compare it to the equivalent heating value of a DC system. Some low-end instruments employ a technique known as average sensing, sometimes referred to as average RMS. This entails multiplying the peak AC voltage or current by 1 over the square root of 2, or 0.707. For electrical systems where the AC cycle is sinusoidal with undistorted waveforms, this can produce accurate and reliable results. Unfortunately, for other AC waveforms, such as square waves, this calculation can introduce significant inaccuracies. The equation can also be problematic when an AC waveform is nonlinear, as would be found in systems where the original or fundamental waveform is distorted by one or more harmonic waveforms. In these cases, we need to apply a method known as true RMS. This involves a more advanced mathematical calculation that takes into consideration all nonlinearities and asymmetries that may be present in the AC waveform. In this equation, N equals the number of measurements made during one complete cycle of the waveform, or sample rate as it's termed. The higher this number is, the more accurate the RMS calculation will be. This is because the higher the value of N, the higher the order of harmonics this formula can accommodate. Always look for true RMS when selecting a meter. Less well known are the terms true InRush and true Megohmmeter. These are unique to AEMC and represent advanced capabilities. When an electrical system or device is turned on, voltage and current initially spike before settling down to a steady-state operation. This phenomenon is known as startup InRush, and it can be an important consideration when monitoring your electrical network for events that could affect the performance of your facility. InRush is also a critical factor in determining the proper sizing of your network. Most instruments can only measure InRush in systems that are initially powered off. Basically, these instruments measure current and voltage starting with the initial powered down state, through power up, and finally steady-state operation. This usually occurs within the first few seconds after startup. The instrument then compares the power up peak to steady state and, depending on the threshold criteria used, displays the InRush reading. AEMC's true InRush function adds the unique ability to measure power-up events from devices on a network that is already energized. In addition to the initial power-up event, true InRush can also detect subsequent power-up InRush events that meet user-defined threshold criteria. True InRush captures these overcurrents, making it simpler and easier to size complex installations correctly. Another term unique to AEMC is true Megohmmeter. To understand its meaning, consider the general principle behind how Megohmmeters operate. Basically, these instruments apply a constant voltage to the insulation under test, measure leakage current on the conductor, and then calculate and display resistance using Ohm's law. Unfortunately, holding the voltage constant can be a challenge at lower resistances. To accommodate this, most Megohmmeters lower the voltage level in this situation and continue with the test. This may introduce a level of uncertainty into the data, since ideally all measurements within a test should be made at the same test voltage to ensure a true comparison amongst the readings. AEMC's true Megohmmeter functionality ensures that the test voltage remains constant throughout the test, irrespective of how low the level of resistance. If for any reason the voltage cannot be held constant, true Megohmmeter instruments will end the test. This ensures complete voltage consistency across all measurements in a test, enabling you to compare results with a high degree of confidence. This concludes our quick explanation of true RMS, true InRush, and true Megohmmeter. All three terms speak to AEMC's commitment to providing you with the most reliable and accurate data. If you have further questions about these or any other topic related to our products, please contact AEMC Technical Support. And be sure to check our YouTube channel for instructional videos about other topics in electronics, including the many products offered by AEMC.